In this short video, we're going to learn how to solve a multi-plant monopoly question when one firm has a constant marginal cost. Perfect Comfort is a multi-plant monopolist producing cozy cat beds. They face an inverse market demand curve of 20 minus 0.5 Q and a marginal revenue curve of 20 minus Q. Plant 1 has a marginal cost function of 2 plus 0.5 Q1, and Plant 2 has a marginal cost function of 6. The total output in this market is the sum of what's produced in plant 1 and what's produced in plant 2. Just so we're clear, Q1 is the number of cat beds produced in plant 1 and Q2 is the number of cat beds produced in plant 2. Our goal is to determine Perfect Comfort's profit maximizing output and price and to determine how they should allocate their production between the two plants. What do we need to know in order to answer this question? We need to know each plant's marginal cost curve as well as the inverse demand curve. How are we going to solve this question? Well, it turns out because of the constant marginal cost in plant 2, we are just going to directly apply the optimality condition, which says we need the marginal cost in plant 1 to equal the marginal cost in plant 2 to also equal marginal revenue. So this is like a combined optimality condition where we know marginal cost has to equal marginal revenue to maximize profit, and we also know that the marginal costs have to be equal across plants to be optimal. So by creating this like three-part equality, we'll be able to solve for Q1, Q2, and Q. Once we have Q1, Q2, and Q, we just substitute Q back into the inverse demand curve to find the optimal price. So let's solve this question. Here's what we know. We have the inverse demand, associated marginal revenue, we have the marginal cost in plant 1 and in plant 2, and we also know that Q, the total output, is the sum of what's produced in plant 1 and what's produced in plant 2. Our goal is to find the profit maximizing quantities and price. Step 1 is really just applying that optimality condition, which is that the marginal cost in plant 1 has to equal the marginal cost in plant 2 and also has to equal marginal revenue. So filling in what we know, we get 2 plus 0.5 Q1 equals 6 and also equals 20 minus Q. From here, I find sometimes students don't like these big sort of multi-part equalities. Don't be bothered by it. Instead, break it up into two parts. We can rewrite this as 2 plus 0.5 Q1 equals 6 and 6 equals 20 minus Q. And then we're going to add one more equation because notice we have a Q1 in equation 1 and we have a Q in equation 2. We have to remind ourselves that Q is equal to Q1 plus Q2. So notice that we have three equations, 1, 2, 3, and we have three unknowns, Q1, Q2, and Q. These are all linear equations, so we should really easily be able to solve for our three missing values from this system. How you do it is up to you. I'm going to start by solving equation 1 for Q1 because it seems like an obvious place to start because that equation has only one unknown variable in it. So I have 0.5 Q1 is equal to 6 minus 2, which is 4. I multiply both sides of my equation by 2, and I get that Q1 is equal to 8. We'll call that equation 4. So we're like halfway there already. We know what Q1 is. So from here, I've added equation 4 that Q1 equals 8, and I'm also going to update equation 3. Equation 3 can be rewritten as the total output Q is equal to 8 plus Q2. From here, what I'll do is I'll substitute this updated version of 3 into equation 2. So I'm noticing that equation 2 has a Q in it. I know how to write Q as a function of 8 and Q2. So I'm going to incorporate that adjustment. So I have 6 is equal to 20 minus Q, where Q is 8 plus Q2. Parentheses matter here, so please be very careful. We're going to distribute that negative, so 6 is equal to 20 minus 8 minus Q2. Notice that from the substitution process, I am now able to solve for Q2. So my goal is to solve for Q2. I notice it's negative, so I'm going to shuffle it over to the left-hand side of the equation, and I get Q2 is equal to 12 minus 6. Finally, I write that Q2 is equal to 6, and we can call that equation 5. So we're almost done. We know Q1 is 8 and Q2 is 6. The last thing we need to do is we need to find Q, total quantity. So we're going to substitute that Q1 equals 8 and Q2 equals 6 into equation 3. Just so we're clear, I'm just adding 8 plus 6. So we get that the total quantity Q is equal to 8 plus 6, which is 14. We can call that equation 7 if we wanted to continue numbering here. No, sorry, 6, not 7. I got a little carried away. And then finally, we figured out that the firm is going to produce 14 total units, 8 of them in plant 1, 6 of them in plant 2. We finally need to figure out the price they're going to charge. We'll do that by substituting the total quantity of 14 into the inverse demand curve. So P is equal to 20 minus 0.5 times 14. 20 minus 7 is equal to 13. So they're going to charge $13 and they're going to sell 14 total units.